We've been talking about centralized and decentralized markets, and batching transactions is one way of sort of interpolating between those two extremes. We've already talked about the role that batching plays and how Uber currently matches riders with drivers. Let's look at another example in terms of the New York Stock Exchange. So the New York Stock Exchange is kind of like as decentralized as a market gets, right? Anyone can show up and place a buy or a sell order at some price on any stock that they want during opening hours. And transactions are processed on a first come, first served basis. So as soon as you have a buy order that's quoting a price at least as much as some sell order, those get matched, the stock gets traded, and the transaction is completed. Now, an issue that comes up, given the fact that transactions are executed immediately in first come, first served fashion, is something you've probably heard of, high frequency trading, or HFT. So let me give you a simple example of how high frequency trading comes up. So imagine that you submit an order to buy one share of, let's say, Facebook stock at some price, say a price of $200. And maybe your buy order remains outstanding because there aren't any sellers that are willing to sell for $200. Maybe all the standing sell orders are at prices $210 or higher, whereas you were only offering $200. Now imagine that the Cambridge Analytica scandal hits and you suspect that Facebook's stock price is about to drop dramatically. Well, now the race is on. You want to cancel your standing buy order, but opportunistic sellers want to beat you to it and clear your order at the now lucrative price of $200. So whether or not that transaction gets executed depending on who gets to the market first, whether you're able to cancel your order before some seller comes along and clears it. And this is just one of many scenarios where speed translates directly into dollars on the New York Stock Exchange. In fact, in the United States alone, a conservative estimate is that the high-frequency trading industry earns several $billion a year. And from this, we can conclude that apparently there are significant arbitrage opportunities at the millisecond time scale. So for example, between essentially identical index funds on the Chicago and New York exchanges. Now with this background, knowing just exactly how much money is at stake, maybe it makes it not that surprising that in the year 2010, there was a company called Spread Networks, and they invested $300 million into covertly building a high-speed fiber optic cable connecting New York and Chicago. Chicago also features a quite big stock exchange. Now, of course, there are already cables between New York and Chicago. So what was the innovation of the new cable being built by Spread Networks? Well, rather than doing things like following railroad lines or dodging mountains, Spread Networks cable went directly from New York to Chicago, thereby shaving an entire 3 milliseconds off of the round trip time between New York and Chicago, bringing it down from 16.3 milliseconds to 13.3 milliseconds. For a little context, a blink of an eye, that would be 100 milliseconds. So we're talking about one order of magnitude faster than the blink of an eye. And this improvement was indeed enough to make a ton of money, right? So given the setup in the stock exchange, all that matters is that you're a tiny bit faster than your competition. That's good enough. The joke then, at the time, was that the next innovation would be a cable that tunneled directly through the Earth, thereby avoiding Earth's pesky curvature. In reality, already by 2011, that's the next year, competitors were already switching from fiber optic cable to microwaves to get even better round trip times, because the refractive index of air is just a little bit less than that of glass. Now, you hear all this, and I think maybe your response would be, boy, this kind of seems like a waste. I mean, it seems like there should be better uses of resources than building infrastructure to participate in the high-frequency trading rat race. So the question then is, could we redesign the New York Stock Exchange to mitigate the incentive to engage in high-frequency trading? This is exactly the type of question I hope you find yourself more prone to asking after you complete this online short course, right? We grow up with the New York Stock Exchange. It's easy to believe, it has to be this way, or this is the best way it could possibly be. There couldn't possibly be a different design, but that's just not True. And so whenever you see a real world system, even if it's a famous one, like the stock exchange, you should ask yourself, are we happy with how this is functioning? Does it have any problems? And if it does have problems, you should ask yourself, could there be a different design that would not have those problems? So if I gave you a clean slate to redesign a system, like say the stock exchange today, how would you do it? Would you just replicate the original design, or would you do something different? That brings us to an elegant solution proposed by three economists, Budish, Crampton, and Shim, who proposed to batch transactions on the New York Stock Exchange and process all of the transactions in a batch at the same time at a common clearing price. So for example, imagine that we break time into 1 second intervals. So the exchange just watches a second's worth of transactions for some stock. At the end of that second, it sort of executes any cancellations that were submitted. So anyone who wanted to cancel an existing buy or sell order, that gets taken care of first. And then with the remaining buy and sell orders, right, maybe some of which were submitted in the previous second, some of which are maybe like old ones from a long time ago that just haven't been executed yet. In any case, with all the remaining buy and sell orders after processing the cancellations, the exchange then executes as many trades as possible, all at a common price. To see what I mean in a concrete example, imagine, say, we had 5 buy orders and 5 sell orders come in the previous second. We want to figure out which of them to match with each other and at what price should we match them all. So what we're going to do is we're going to take those buy orders, the 5 buy orders, and sort them from most lucrative to the other side to least lucrative. So that'd be from the highest buy price to the lowest. And let's suppose those 5 buy orders are for the prices 10, 8, 6, 4, and 2. For the sell orders, we're going to do the same thing. We're going to have the sort of most attractive one to the other side first. So that's going to be the seller willing to sell at the cheapest price. And then we'll see increasing sale prices from the front to the back of the list. So how do we decide who gets matched? Well, if a buyer is matched with a seller, it's important that that buyer was willing to pay at least as much as that seller was willing to accept. So the buy order price should be at least as large as the sell order price. So we just start at the left. We say, okay, so here's someone who's willing to buy at 10 and sell at 1. Clearly, they would be happy to match with each other. Then we move on. We say, here's someone who's willing to pay 8 and someone who's willing to sell for 3. They would be happy to be matched. Then we go to the third one, someone willing to pay 6, someone willing to sell for 5. They're happy to be matched. But then when we get to the fourth column, now all of a sudden we have someone offering 4, but someone only willing to accept 7 for the sale. So that would not execute. So we just scan from left to right and we see for how, we look for how long is the buy order at least as large as the corresponding sell order. And those are going to be the matches in this particular 1 second interval. So that's how you would decide which orders actually get executed in a given interval. There's also the question of what should the price be. So the price is going to be the same for everybody, and everybody should be happy with that price. So it's got to be at least as large as all of the sell orders, and at most as large as all of the buy orders. So in other words, in this case, a clearing price of anywhere between 5 and 6 would be fine. So why is this a good idea? Well, if you have one batch processed per second, now all of a sudden an extra 3 milliseconds of speed is not going to be very valuable. Okay, once in a while, you'll be able to sneak into an earlier interval than you could before if you happen to be right on the boundary. But most of the time, it won't matter. Those extra 3 seconds will not change anything. You'll wind up in exactly the same batch as you would have been otherwise. And the longer you make this interval, the less likely it is that 3 milliseconds will matter. So if you made the intervals 10 seconds rather than 1 second, all of a sudden it would be very unlikely that the extra 3 milliseconds of speed would have any effect on what happens. Now, unlike the Uber example, where they, literally their current system is batching requests and doing this sort of centralized matching of riders to drivers, this suggestion by Budish, Crampton, and Shim, that has not been adopted as of this point, speaking in July 2020. As you can imagine, there's a lot of inertia to make any changes to the New York Stock Exchange. And you can also probably imagine that there are some parties that are lobbying very heavily against this particular change, like pretty much anybody who financially benefits from high-frequency trading, which, remember, is generating several billions of dollars every year. However, the change is conceptually simple, and, the authors have put in some work trying to drum up support for it. So, we'll see. But it's not impossible that some version of this could be implemented in the next 5 to 10 years or so. You could argue that, maybe the computerized version of the New York Stock Exchange, when it was first rolled out, perhaps it should have been implemented in this way anyways. I mean, the first come, first serve model is very natural if you're just trying to simulate the process that was being done by humans on the trading floor. But, once you're computerizing it, maybe the batches would have made sense from the very beginning. So in effect, you can almost think of as the strong incentives for high frequency trading are really caused by sort of a bug in the original algorithmic implementation of the New York Stock Exchange.